Well, hello, David. How are you doing?
Hi, Leighton. I'm doing wonderful. Thank you. Thanks for having me today.
Absolutely. So, because this is your first time on this channel, what I'd love you to do is kind of give us your background. Introduce yourself, give us your background, and tell us how you got here.
Okay. Yep. Long, strange journey like most. So I'm David Olson. My company is Sustainable Growing Solutions. We make microbial inoculants for commercial agriculture, as well as some specialty fertilizers and microbe foods. So my background is I'm a sixth generation farmer, second generation scientist. Grew up on the family farm, so grew pears and apples and a bunch of different cereal crops and other row crops and vegetables and seed crops. So pretty diversified. And my dad started working with organic inputs about 50 something years ago. Made me the right age to start doing the field trial stuff with that. So it's, we started working with all these different inputs, and it's, the same questions that everybody has, even still is like, what is this product? How do you use it? When do you use it? How much do you use? And what are you trying to achieve with that? Or what's the outcome you're looking for? And how do you measure that? So all those same sort of things. So I kind of cut my teeth doing all those kind of field trials as a kid. So start very familiar with things like, fish hydrolysates and humic acid and fulvic acid and, just a whole bunch of other types of organic inputs. So, being a farmer makes you a pragmatist, right? So you have to, it has to be practical and implementable and repeatable as a tool, or else it's just not viable. So we did that for a few years, and my dad actually started working with biological inputs. So his first biological input was several different bacteria that were developed actually as part of the NASA program. And so that spun off into an ag application. So we tested that and got actually some pretty good results out of it, learned a lot. And about 10 years after that, my dad developed his first biological product. So that was over 35 years ago. It was about 12 different species of high functioning microbes. So just kind of a blend of individually cultured microbes that we just mixed together and slap a label on it. So it's 4 different species of mycorrhizae, Pseudomonas, several different bacillus. So it's a couple different trichoderma. So it was a good product. Sometimes it performed fantastic, and other times we really didn't see anything at all, and might be just on the other side of a fence line. And so we kind of struggled with that for a little while because it really needs to work every time you use it with a predictable outcome. And when we started looking at the production soils that we were working in across the country, we realized that a lot of these production soils were very impaired from a biological standpoint. So a healthy soil should have 1,000 different species and 1 billion microbes per gram. And what we're finding in some of these really heavy, production ground is oftentimes you'd have only just a few dozen species and maybe a few 100,000 microbes in population. So you'd have, if you start thinking of the soil as an ecosystem and this chain of interdependencies in terms of relationships of microbe function, from an ecosystem standpoint, these were actually broken. And so we realized that the problem with that initial product was sometimes that product would land and there would be species, in situ that would work with those introduced species, and they'd successfully colonize and they'd do their jobs. And that's when we'd see the benefit. But other times they'd land and they didn't have a cohort that they could work with, and they failed to colonize or they failed to do their jobs. And so that's when we didn't see the product perform. So the more we realized that the impaired biology, the broken ecosystem of the soil was the fundamental problem, it really changed our perspective on how we look at microbial inoculants, I think, to a way that's unique, mostly to us, in that our objective is not to just put in a handful of high functioning species. We already tried that and a hit and miss success with that. But our mission became restoring the entire soil biology. So thousands of different species and very, very high populations. So we're looking to reestablish all of the beneficial functions that the microbes do for the plants, which is myriad, and we can talk about those at length. But and not just one species that does that job, but literally dozens. So no matter what plant, species, or what the combination of environmental or soil conditions that will have microbes that have the ability to colonize and step forward and do those beneficial functions for the plants. So that really changed our paradigm, our thinking of how microbes work in the soil and what products we needed to produce to have a reliable, beneficial outcome every time we use it, a reliable outcome. So our credo here is maximum biological diversity, and it's going really well. We've got 9 different products that are microbial inoculants that are registered, all of them organic. And so we have different sets of biology that we use for different sets of functions. So our most basic product is our most diverse one is called MetaGrow ST. So that's the one with the 20,000 species. And so that's the one that we use as kind of creating a foundation of biology and repairing the entire soil biology. And from there, we start narrowing that population down, but also tailoring its metabolism to do particular functions. So that's when we get into certain types of interventions and addressing particular limiting factors to soil biology. So that's kind of a long ways to get there, but I think I answered your first question.
No, that's fantastic. I love that you cut your teeth early on in science. Not a lot of people get to do that, and more importantly, learning the lessons of the bigger picture, the 1,000-foot view. I was very blessed. I got, long story short, I got to meet Dr. Leighton, and I brought her a product called fish mulm, which is fish poop, but it isn't, because when the fish goes to the bathroom, it's like poof. It's it's an organic matter suspended in a water column. And I had noted, way back when I had played with fish and plants and sold my baby fish and my healthy plants back before, and made a good living. So I knew that there was a relationship to the two of them. And prior to meeting Elaine, I had gone to a conference called the Second Annual World Aquaculture Aquaponics Conference down in Cancun. That's where I met, incredible heavy hitters. We talked about aquaponics versus aquaculture, a deeper dive into water quality, aeration, dissolved oxygen, a deep dive. And so from there, I left and I started going to aquaculture companies and pulling their manure or their sludge or their byproduct and playing with it. And so I got an incredible experience of understanding that there's a whole world of aquatic microorganisms as well as terrestrial microorganisms. Microorganisms. Let me spit it out. But what was really fascinating was the understanding. Well, it was more of a question to Elaine. I'm like, Elaine, look, I see the same testate amoebas in my aquaculture product as I see in the compost product. Aren't these organisms interchangeable? And she's like, no, there's aquatic microorganisms and there's terrestrial ones. So that sent me on a rabbit hole. And, I don't take no lightly. I want to really dive down it. And what I come to realize was that prior to the great human expansion, which is when we just took over the globe, there was mass migrations. And those mass migrations introduced aquatic organisms to the terrestrial environment. And the terrestrial organisms were introduced to the aquatic environment during, wet seasons, spring, floods, ice melts, snow melts. So there was this similar function in these organisms or similar species amongst them. Now, there are specialties. There are ones that really don't thrive well in a terrestrial environment unless they're in a soil aggregate. Now, once you get into a form of aggregates, you have, all these different conditions from anaerobic to, suboxic to all the way to aerobic and everything in between. So that gives them an environment in which they can continue to live. Although as soon as you plow it, till it, you kill it, right? So this gets into more of a understanding of how soil functions.
Well, yeah, no, and you bring up a bunch of really interesting things there. So, of course, we do a lot of metagenomics testing of our products as well as this, our production soils all over the place. And of course, you end up with all these, names of genus and species. It's like, I don't know that one. What does it do? So you end up doing all this research on it. And one thing that definitely impressed upon us very early on was that microbes are incredibly adaptable. So they have, these long gene sequences, and yet only certain ones are active at any given time. And they will activate gene sequences and adopt different metabolisms. So of course we have things like facultative microbes. They can have an aerobic metabolism or an anaerobic one, depending on what the conditions are. So as we're documenting all these microbes, like one that we came across fairly early on because it was in a competitor's product, we looked it up and it's like, oh, it's genus Mariana something or other. It's like, oh, it's an ocean microbe, and where it was first documented was at this deep sea hydrothermal vent. So it's like 1,000 feet deep and 140 degrees Celsius and a pH of, I don't know, 10. And it's in a sulfur energy chain. So it's no photosynthesis involved in its entire, little micro ecosystem. It's like, wow, what a strange little guy, what's it doing in their product? But we got to know the name. And then as we're doing all the soil analysis, we see that same damn microbe show up in the soil. I was like, oh, well, genetically, it's the same thing. But, metabolism wise, I'm sure it's doing a very, very different job in the soil than it was when it was down in the volcanic vent. It was like, but that's how adaptable microbes are. They will find a way. Nature will not have, some opportunity that is not exploited or taken advantage of by some sort of life. And so it just gives us a great deal of admiration for the tenacity of life and its adaptability. So when you talked about your fish poo, I'm like, yeah, that's kind of exciting because you're going to have enteric, microbes that come from the gut of the fish, and some of those are pretty dedicated to that. So maybe we wouldn't see a lot of them, in the soil profile, but there's a ton of enteric microbes that commonly live in soils. And so, and that would tend to be, especially in, like a lagoon sort of scenario, tend to be probably a pretty anaerobic environment, but lots of amino acids and other cool stuff. It's like, I like, and it's going to be a consortium, which I always like. So it's like, yeah, I can see all sorts of fun stuff coming out of that.
So here's another fun fact that most people don't know. Fish actually have two stomachs. They have one on the outside, which is that slime that you feel when you pick up a fish.
Uh-huh.
That slime is a protective coating that's allowing the microbes to live between the scales and the water, and they're pulling minerals directly out of the water and pushing them into the fish from the outside. Right? So you're getting you're getting aerobic and anaerobic microorganisms. I mean, that's where I get all my solubilizing bacteria, calcium, potassium, phosphorus, solubilizing bacteria that live in that coating that does come off as they brush against each other and hit the tank walls. And so you're getting all of that in combination. And this will really pop your cork. I used to do conferences called the Science Behind Organic and Regenerative Cannabis Cultivation. And I got thrown into the cannabis world back in 2018 when it was kind of big, booming here in California. And I was giving a conference on the difference between, terrestrial and aquatic. And another part of it was in vivo versus in vitro production of microorganisms. And one of the gentlemen at the conference came up to me after and said, "Hey, I'm Colin Bell. I'm the founder of Mammoth P." And I'm like, "Yeah, a couple of the cats been telling me that I need to talk to you So yeah, tell me more. What are you doing? And he said, well, I cultivated, or I isolated 5 different species of phosphate solubilizing bacteria, and I grow them out, in vitro, and I bottle it and I sell it to cannabis cultivators, because they need lots of phosphorus at flower. And I'm like, oh wow, that's really good. How well does it work? Oh yeah, it works great. He goes, but here's my question. He goes, you said something about in vivo versus in vitro that really made me scratch my head, because I've always noticed that, or wondered, why is it people have to continuously use my product even though they don't change my soil? I said, wow, that's a good one. Well, bottom line is that it's like taking a rich kid out of his mansion with, who has never done anything for himself, and throwing him in the ghetto. How long do you think he's going to last? You're throwing these microbes into a very established and hostile environment. And I go, now flip the switch. You take that ghetto kid, you throw him in the mansion with all that access to everything. He's going to thrive, right? And so we talked a little bit more about this, and he was like, well, can you help me expand my culture, because I definitely understand genetic drift. And after a period of time, the product just gets more inbred and less functional, more inbred, less functional, because they're not reculturing every single time. And so I agreed, and I sent him some fully aerobic fish mulm, some facultative, so like ppm of like 5, and then I sent him some anaerobic, but I had stabilized it so it wasn't like horrifically smelly. And I sent it to his lab in Colorado, at which point he connected me with what was supposedly his top scientist. Now, this kid, because he was young, totally screwed up. He threw him up in the attic and forgot about him. Well, lo and behold, one of them exploded, right? Because they build up that hydrogen sulfide to a point where the container can no longer take it. So it blew up, and it went through their entire air system. They had every biological alarm in the facility go off. They had CDC, freaking fire, rescue, every organization show up, and a couple $1 million later to clean the whole thing up and start over again. So
Wow.
The reason I tell you that story is because, one of the things is lack of respect to these organisms. Like early on in my work, when I was developing these products, I would send products out to people. I'd be like, hey, this is a puppy dog or a kitty cat. And you got to feed them, and you got to water them. You got to take care of them. You can't just, throw them in your garage and forget about it. And I had more people come back to me and complain, oh, it smells, it's no good, blah, blah, blah. And I'm like, no, I told you to use it when you got it, not just ignore it or forget about it. And that's been the biggest issue as far as how to stabilize and create shelf stability in these really highly concentrated biological inoculants. So I'd love to hear, that road that you went down to get to where you are.
Sure. Yeah, and that is a really good series of points you made. One, we always love the biology that we get out of the fish hydrolysates, but you made me think of it now in a whole new dimension. So I'm pretty excited to think through that. As far as the culture stasis, people can make their own fresh compost teas and things like that, which are can be a very useful product. But of course, it's time sensitive, right? I think of it as like a ticking time bomb.
Absolutely.
It's like you finish it and you need to get it out there. And if you don't, it can go anaerobic and produce a bunch of metabolites, and then that's how you burn things. So the anaerobic metabolites that get produced are things you definitely wouldn't want to put on your plant. It's all sorts of toxic and caustic sort of materials, alcohol, ethanol, glycol, aldehyde, formaldehyde, ethane, methane. It's like it's a whole cocktail of stuff. You just
right. That's just a few, right?
Yeah, that's just a handful of the bad ones. But so we focus our biology in a very aerobic way, environment. So of course we do still, we do still have a lot of facultative microbes, but the way we produce our product, even if we started with a handful of anaerobic species in the mother culture, the way we propagate things, they just never really get an opportunity to propagate. So we really end up with this very aerobically dedicated set of metabolism. Then we put them into stasis, and there are several different stasis ways you can put microbes into stasis. And we felt that you do lose a small portion of the population. There's some actinomycetes that can't go into stasis, and so you actually are going to kill off that part of the diversity of your biology. But nonetheless, you end up with 75 to 85% of that species diversity still. And it's important to put them in stasis because they become incredibly durable. We've done some experiments where we've literally stored our materials for years. Even we had stuff we stored out in the, this is on purpose, out in the sun for 18 months in the desert, and then looked at the populations again. And I think we had about a 10% lays in the population, so we only lost about 10%, which was really good. And there's a number of advantages. One, you lose that time-sensitive element that you don't have to put stuff on right away. You can buy in large lots, and for my commercial growers, it's really important because they have to report the lot numbers of all the materials that they're buying. So they can buy, a truckload or a tanker load, and they'll have the same lot number all season long. And they don't have to be worried. It's like, oh, well, what if I, don't use it up all by the end of the year? It's like, it's fine. It'll be just as good, when you start up next season. So the other things that's really important about the shelf stability is just the durability of the microbes. So they've kind of hunkered down at that point where they're either doing no respiration or a very, very minimal form of respiration. So there's like 4 different forms of stasis that the microbes can commit themselves to. And what's nice is once they're in that stasis state, you can expose them to conditions that would kill them if they were actually in active respiration. So levels of salt pressure, EC, caustic, pH, all sorts of conditions that otherwise would just be absolutely terminal for them. And they'll stay hunkered down and won't come out until conditions are suitable for them. So you could, we do tank mixes with some pretty tough synthetic fertilizers. So like 1034O being, a pretty vicious one, or even, UN32. You would think is like, oh man, that's just going to destroy the biology. It's like, nope, it's going to stay hunkered down until it gets diluted enough where they can tolerate it, and then they will come out and start, becoming active and colonizing and doing their jobs. So it's allowed us to do some pretty innovative things in terms of tank mixes, as well as kind of extending the efficacy of like a foliar spray. Because we can have something that's a mode of action that would be terminal for, say, the in situ biology, and yet mix our biology with it. And our biology stays in stasis until the active component of the spray material wears off. And then our biology starts to wake up and flourish, and then reoccupy all those canopy spaces. So it really extends the viability of those some of those pesticidal functions.
Can you talk about your technique, or is that proprietary for the suspension?
No, that's one of the few things that I won't talk about. There are, as I said, a bunch of different ways to put microbes in stasis. So I always tell people to look at food science or food preservation. It's like, okay, so we pickle stuff. It's like, well, why do we pickle stuff? It's like, well, it's a really low pH, and at a certain point, all the microbes check out. Don't necessarily kill them, but they just can't be active at that low pH. It's like, okay, well, we do jams and jellies, so there's osmotic pressure from all the salts. So you raise the osmotic pressure to the point where none of the biology can be active. Not killing it, but it can't be active. Same thing with salting stuff, so you put it in a brine. Too much osmotic pressure can't be successful. People are like, oh, well, if it if it freezes, will it kill your microbes? It's like, well, if it did, we would freeze stuff to preserve it. All it does is, temperature just slows things down.
Yep.
So, that doesn't hurt them.
No, that's really well said, and I'm glad you shared that. I went through a similar process where early on, like I froze my compost extract, and that worked great. But then you get into the logistics of moving ice cubes, which is where we targeted. We want little cubes that could get sprayed out on the field.
Yeah.
And it worked great, but then when we moved into, okay, how are we going to get these to the client? And then you start realizing, oh, I got to move by freezer truck. It's got to be packed in styrofoam coolers. It just became too cost prohibitive. So I'm like, all right, well, we're not going to do that. So I went into pH suspensions, and similar situation. It was like, yeah, it's great, but we lost too many of the organisms. I'm really not happy with that. Plus, I don't want to, adversely affect on the other end with putting out a real acid or a real base on the existing indigenous population. It did work, but I just felt the efficacy was not the direction, or the moral component was not the direction I wanted to go in. And then I played with sugars.
Yeah, we have to live in that real world. I mean, we can't be tipping the pH of the soil in a way we don't want to. Right. And it also has to be just practical to implement. It's like not many growers are going to have a cold storage plant or a big cool room that they can put stuff in for.
Right. So
it's like, got to figure out a way to work around that.
So what I ended up doing was actually I moved into dewater, and that's where I ended up with most of my products. I still sell to certain clients my humic acid, which is that highly, highly concentrated biological diversity that will go anaerobic if it's not used right away. But for public, no, I won't sell that anymore. And so what I ended up doing was I tried a bunch of different equipment. All of it was too expensive. Some of it did a good job. Some of it wasn't, efficient at scale. And then I moved into pressing. And what I found out was that I could press it to a point where I had the moisture content at only about 40%. And I could fluff it up, put it in a bucket. And my God, I had product for 17 years that was better when I opened it up than I was when I produced it. So that's where I ended up going. And, again, it can be scaled. It's just not something I desire to do anymore in my life. I built empires, ran them. It was fun. It was great. It's very stressful at the time. But I'm at a chapter in my life where I like to take on clients that I want to work with and not be a slave to, oh my God, I need to, keep the employees busy, keep manufacturing up. So that's kind of where our paths kind of have obviously shifted. But again, it's great to have these kinds of conversations with people that understand those kinds of issues as far as like, how do you get to market? You might have the greatest product in the world, but getting that to market and getting the word out is a challenge. I don't know how you did it, but breaking into farmers, my God, they're the toughest cows in the toughest bulls in the paddock.
Yeah, that was an interesting experience to start marketing. We were really marketing biology to commercial agriculture as long as 20 years ago. And initially, agriculture is mostly relationship-driven business. And fortunately, I had a very large network of growers I had great relationships with, which gave me, I guess, a little bit more grace than they would have given the average guy who walked through the door. So I'd start to tell them what we're doing and why we're doing it and how we're doing it and, what the benefits were. And a couple guys, good friends of mine, said, if it was anybody else, I'd throw you out of my office right now. But you're saying it, so I'm listening. Doesn't mean that you got the business, but at least they're willing to listen. So, now, there's been, thanks to so many people, you mentioned Elaine, so Elaine and so many other people really carried the torch and educating, a whole bunch of people. And now there's a core level of awareness, I think, of the need for and the function of biology. There's still quite a few, questions from people about, it's like, what product do I use? How do I use it? How much should I use? Where should I use it? What's my benefit ratio? It's like those are all, and how do I integrate that into my own particular farming circumstance? And those are all extremely, legitimate questions that have to be answered. But now we have kind of a core audience and a customer base across the country of people that are having success. And so they're kind of forming their own little community and being really open and sharing their success and also their failures of things is like, hey, I tried this, it didn't work, don't go there. Or I'm doing these things, I'm pretty excited, and this is the path I'm on. So right now we're in like 70 different crops. We're pretty active in about 20 different states. We have a whole distribution network across the country. It's really exciting and fun to see. We feel like we're really making a difference. We're helping growers cut back on their synthetic fertilizers. I was just on a conference call with Nebraska this morning, talking about some alternative forms of fertilizers and cutting back the fertilizer prescriptions by about 50% with regards to the nitrogen, about 35 on the phosphorus. And those are achievable goals, things that we've been pretty good about achieving on a regular basis under a broad range of crops and conditions. So that's been really successful. And because we're getting the biology to perform and feeding those plants and attaining a much higher nutrient status of the plant and much more efficient photosynthesis, we're also seeing kind of a proportional drop in the pesticide costs. So less fungicide sprays, less insecticide sprays. And so the growers are enjoying a huge benefit out of that. Just less production problems, higher quality product, higher yields, and actually even lower production costs by the time you add it all up.
So if you're at 40, go ahead. Sorry, let me finish your thought.
The growers are just in a pinch, right? So commodity prices have not gone up. They've in general kind of gone down. And yet all of their production costs and labor and insurance and everything else, all their overhead categories are all up. So, there used to be a lot of pushback from growers. You get the typical, it's like, well, that's not how daddy did it. And so I'm not even interested in exploring what you have to say. But they're so pressed and so under pressure that they actually, the receptivity is, I know that I need to change something. I don't know what the answer is necessarily, but I know I have to change something. And so that creates a different dynamic in the dialogue. We most of the time are spending being problem solvers, not product salesmen.
Yes, it has been a couple of key factors was COVID. People were forced to stop and think. Right. And that got a lot of people questioning, well, why am I working so hard? Where's my food coming from? Why do I feel like shit? Why am I on all these medicines? And that kind of opened up a really big door, at least from what I saw. Prior to that, people were like, oh, you're a soil biologist? What the hell is that? Well, there's no life in the soil. That was the pushback I got. Except for the few and far that I met in between that had at least an understanding that there was, as above, as below, and it was critical that the soil health be maintained. But needless to say that, that was probably the big eye opening. And then Ukraine was the next big, like, oh my God, my fertilizer price doubled. And I actually got a client, he's got 500 acres of corn and beans. So I've been talking to for years. And just like what you said, well, that's not what we've been doing. I know we need to find a different way. But I'm really scared. Like, I can't get crop insurance if I go fully biological. Like, I have all these restrictions. Plus, if I lose my crop with no crop insurance, I'm done. Like, I'm out of business. There's no coming back from that. And then fertilizer prices went up, and he was like, all right, I think I'm ready to do it. And so I held his hand. I mean, we talked probably daily for months during the initial, application phases and how to put it down. And again, my product comes in as he got liquid, but he also got solids. So the solids are like it's basically super fine compost. So it's organic matter that has been colonized, similar to like biochar, with all the advanced organisms. And so you put it in the soil, and then it activates. Within 24 hours, all of these guys come back to life because they've basically been put in a situation where they were slowed down to a point where they really had no respiration. And all it took was water and soil to get them back to life. So, and he's now 100% biological. He uses hydrolysate, he uses kelp, but he doesn't use any fertilizers whatsoever or pesticides. And he had a bumper crop last year. He had 250 bushel per acre in corn and something crazy in beans. I forget what it was, but it took 3 years, right? It took a commitment on his part to make that happen. And I think what you're great at is you're a bridge. You give them the ability to slowly come off those synthetics, and maybe they continue to dabble. Like I work with some cannabis farmers who I have great respect for, industry leaders, in the community, and they're 90-20 now or 90-10. So they still use 10% of salt fertilizers in different forms, some of them organic, some of them inorganic, but they're 90% biological. So yeah, there is a balance. Like Elaine, when I first got to know her, she said, if you ever mix a synthetic with a biological, I'm going to kill you. She was like brutal on me. And I was just, I'm like, all right, I'm going to try this.
She had a lot of black and white.
Oh God, yeah, she was. And so I'm like, all right, well, that means I got to try it now. And I did. I was able to use up to, I think, 20-25% synthetic without killing the biology. Now there was a tipping point. I definitely lost a lot of diversity. If it was applied too thick, it killed the plants, it burned them. So it was a whole nother rabbit hole that I decided, I don't want to chase that rabbit. I want to go back into more of a central purist approach to getting people the organisms without trying to tell them or get them to balance, which, I use this term, don't be a moron. Because typically, like, if a little's good, maybe more's better. No, that's the wrong path. So anyway, that's kind of like
a lot of our connection problems are just self-inflicted from exactly that.
Yeah, and that's so hard because you can't babysit them. You can't tell them how to do their job because they're going to get pissed off at you. So you kind of got to step back and let them learn the hard way. But then there's a point where if you let them learn the hard way and don't support them, now they're going to badmouth you. And, that's a whole nother challenge, especially in our industry where they talk. These guys talk a lot. Like they're at the coffee shop bragging about how many bushels an acre, blah, blah, blah. And if you kill someone's crop, man, they're going to badmouth you for the rest of your life. So there's a real delicate balance to that.
Or clog their sprayer or their planter. It's like that's just something verboten. Is like you just don't let that happen. So
no, and that brings up
that
brings up another great point is that a lot of these guys have a hard water, right? And so the natural use of that water starts to calcify inside the spray tips and in the elbows, and it starts to reduce pressure, and you can get blamed for a failure. Like we had a situation this spring, we're applying some product down in New Mexico, and everything was plugged up, or it got plugged up. It started working fine, but it plugged up, and we come to find out that, well, we knew this. We didn't know that he hadn't cleaned his equipment, but we knew that when you will use our product through any kind of irrigation, plumbing, pumps, piping, that it has this ability to descale on a very large level very quickly. But that scale takes time to break down. It's not like if the scale pops off and it goes right through the plumbing and hits the jet, it's plugged. That's it. You're done. But if you give it time for the bacteria to eat the scale that's now exposed on all sides, it remineralizes or it demineralizes, and it becomes part of the bacteria, which is a very powerful fertilizer in itself when it gets out of the field. So yeah, there's that balance. And I don't know if your product has run into that kind of situation.
Yeah, we try not to have the biology kind of stuck in the system, so we apply it typically in the middle third of the irrigation set. So of course they would colonize things like the scale and continue to chew on that. But by and large, we want all of the product out there and not mucking it up. And there's not, I guess, I mean, over time they would chew on that, but it's not going to trigger like a wholesale descaling. And so we haven't had any issues like that.
So are you more in pivot and flood than you are in drip and tube?
No, a lot of drip, very little flood. But yeah, lots of pivots, lots of solid set sprinklers, drip. We don't do much subsurface drip because the filter mesh tolerances on that are typically like 160, 180 mesh. And the fungi are just physically too big to go through that, the spores and the hyphae. And so unless I filtered it and got rid of those, which of course I don't want to do,
Right.
We stay away from those irrigation systems. But it goes through any type of sprayer and all other types of irrigation systems.
Yeah.
We don't do flood typically because the microbes like to stick to stuff. So like we've done flood applications on, like check furrow, alfalfa. So what you see is the head end of the field, you've got this huge response because all the microbes got stuck. And so you've got most of the application happen in the like first 100 feet of the head end of the soil of the field. And you got nothing for the rest of the check.
Yeah.
So the way we've got around that is we'll foliar apply on the alfalfa before they do their flood irrigation, and that seems to work pretty good.
So let's talk a little bit more about your communities. I know you don't want to speak specific, but do you have a fungal to bacteria ratio that you guys work with? Like, is it 1-to-1 or is it maybe?
Yeah. Yeah. It's always a philosophical question. Is like, okay, well, you have to define your terms. So is it by CFU? Is it by biomass? It depends on whether you're talking about hyphae or spores. So the way I usually look at it is, and this was kind of how I think Elaine typically looked at it. It's like, hey, if you can see a spore, fungal spore or hyphae, every third field of view in your microscope, then you've got a good fungal population. And that was kind of regardless of what the bacterial population was. And I hope I'm not misquoting her or mischaracterizing what she was saying there. But so when we look at our stuff under a microscope at that same magnification, we'll have anywhere from 5 to 15 fungi per field of view. So we've got an excellent fungal population. I mean, we're dealing with enormous populations. I mean, sometimes we have hit 1 times 10 to the 12th. So that's 1 trillion microbes per milliliter. So
Gotcha.
It's actually, they're so thick, it's like they're standing on each other's shoulders at that point. So it's really hard to see everything, especially when you've got these big amalgamations or consolidated sets of biology. It's really hard to see everything there. But we do know that when we look at the metagenomics testing, which for anybody who's not familiar with that, it's a process where you look at all the microbes and you do a gene sequence on all of them. And the gene sequence you match to a database, and then by pattern matching that, you can identify what the genus and species is. And by relative abundance, you can tell what the population size is. And and those databases are not complete. So there will be a lot of microbes that don't have names. But we can have as many as 600 named species of fungi in our products.
Nice.
And then usually, we go to a lot of effort. The bacterial side of it is the easy part. it's the fungi that requires quite a bit of art to getting the right populations.
So do you use yeasts and molds as well as like identified saprophytic or mycorrhizae fungi?
Yes. Yep. We have yeasts, microalgae, archaea, some protozoa, not very large populations of protozoa, bacteria, fungi, mycorrhizae, and quite a few different strains of, or not strains, but genus and species of mycorrhizae. So not just the phoric glomus that you usually see out of everybody else.
Yeah, no, and this is something that's really important. I try to bang home to people is that when you're trying to restore a dirt or a very abused soil, you got to put the precursors, you got to put the foundation, you got to put the spores, or not the spores, the yeast and the molds, so that things start growing, so the fungi has something to work off of and work with for itself to colonize. So serious respect for where you've gone. I don't know if you've ever heard of.
That's a good point about the microalgae is, they're very complementary to the rest of the metabolism of the biology, and they are also producing a bunch of lipids, which are medium chain carbons, and that's exactly what the fungi like as their principal carbon food source.
Yep.
And so it's extremely synergistic. Yeah, something that we really, really enjoy. So we have almost as many microalgae in our product as, along with all the other species, as most products that are just only microalgae.
Yeah, again, deep respect, because it is all about communities, and something that a lot of people don't talk about is what we call horizontal gene transfer, or biosymbiosis, which really allow these guys to evolve even in their little niche until they get into the real world or exposed to their new home, so to say. I don't know how deep down the rabbit hole you've gone on those two subjects, but it really explains a lot of evolution.
Fair distance, yeah. So we actually do, that's one of our techniques that we use in epigenetic activation of our populations. So I mentioned, so far we've just been talking about our most diverse product, like Metagrow ST or Metagrow 5X Plus, which is our concentrate. So their objective is to maximum diversity. But we do also tailor those populations for selected functions. So we will take that population and tune it to have a chitin-based metabolism. So that's our Metagrow C, which stands for chitin metabolism. And so all of the microbes that have sustained from that population are ones that have the ability to produce one of the 3 different kinds of chitinase enzyme. So we've tailored a product that the whole metabolism is dedicated to consuming chitin, and a very large and diverse population of microbes that are doing that. And we are also taking advantage of some techniques to force horizontal gene transfer, where we are getting transfer of that function.
Nice. You're down the rabbit hole, man.
Yeah, we're having so much fun, and it's so gratifying, when we can really help the growers solve, really sometimes fairly intractable production problems. So we have another similar product that's called Metagrow. Same strategy of dedicating the microbes to a particular enzymatic metabolism, but in this case, G stands for glucans, and so they are putting a glucanase enzyme and consuming anything that is made out of glucans.
Nice.
So they also have.
So you're
we
creating.
Also use the strategy. Oh, go ahead.
I'm sorry. Go ahead. Keep.
So one more product that we use, that same, again, epigenetic activation and horizontal gene transfer are both strategies involved in this, and this is our decomposer microbe product, so Metagrow D, or decomposer. And again, it's an enzymatically driven metabolism, so in this case, they're tuned to consume cellulose and lignins. So what's cool about that product is the diversity of the biology that comes with it. So these microbes, of course, are all dedicated to a metabolism that's saprophytic right there. So they're feeding on all this dead plant material. That's what their whole function is. And they do that very well. We break down all the crop residue and build soil tilth. At that time, we're fixing a lot of nitrogen in that cycle because we have crop residues that tend to have a very high carbon to nitrogen ratio, and it's one of the few opportunities where the microbes are really, really incentivized to fix nitrogen. So we're just talking earlier today about some test results that we got back. It was like 120 units of nitrogen that had been fixed in that process. Well, that's about as much as you need, for a bunch of crops.
Yeah. And the other piece is the carbon. You're releasing carbon in a form that the biology can actually pull and use to divide and breed and go forward and conquer. So, we should not be talking about NPK. It should be called CNPK, because without the carbon, your N, your P, and your K are either solubilized or they're friggin' organicized, which means that they're non-usable, or you need the special bacteria to solubilize it and release it to the ability for others to consume it. And so, what that product was something I worked on, which was for corn stubble years and years ago, and ended up in a similar place where it was like, oh, well, you should be targeting this. And again, I was like, yeah, I could go down that rabbit hole. Yeah, that'd be fun. But again, I want to take a more broad. I want whoever uses this, I want them to have soil aggregation. I want plant reaction. I want to reduce water. I want it to work on any environment, under any condition, on any plant. So I broke away from a lot of what you're doing in those, we call them sniper products. So instead of using a machine gun, you snipe exactly what you're looking for, or the problem at hand that you're looking to fix. So that's really cool. That's really cool.
Yeah. So our ST and 5X are really our broad spectrum ones. So that's the shotgun, where it pretty much fixes most things. So the other ones I refer to as intervention products. So that's when things have gone, off rails, and you have a real serious imbalance that you're trying to address. And just to finish out that decomposer, so again, it's a very broad diversity, very fungal dominant on that one, because the fungi do the heavy lifting on breaking down lignins, and so just an essential component. So you see these other decomposer, sniper products that you mentioned, it's like they're all bacteria. It's like, okay, well, without the fungi, it's like good luck on all that lignin. And what's neat about this, you look at the species that are there, is like those are all species we already know. They're already in our products. They're dedicated to that metabolism, so they're very effective in that decomposition role. But as soon as they are exposed to a growing plant that's putting out, or even a seed that's started to germinate, that's putting out exudates, that triggers them to change their metabolism. So they change from being saprophytic to plant supportive. So then they start doing all their plant support, plant beneficial functions. So we find that to be a wonderful combination, because here you get the advantage of capturing all those nutrients, capturing all that carbon, improving the soil tilth, breaking down all that residue. But when you plant into it this next season, you've got all those available nutrients and a rip-roaring set of biology that's there to support the plant.
Yep, have it ready to throw a party. So let's talk a little bit about protozoa. Is there a specific protozoa, like a flagellate or amoeba or naked amoebas? What do you have in your product for protozoa?
Almost exclusively will have the encapsulated protozoa, the encapsulated amoeba.
Okay.
I've only ever seen one free living amoeba, and I kind of like it that way, because those are the ones that could potentially be a human health issue. So I don't like to see the free living amoeba. And we do have some occasionally some flagellates, and never ciliates, because we just don't have any anaerobic uh, conditions for them to propagate.
Yep. Yep. Hey,
So, but
they're
we
in
don't.
the yeah, they're in the soil. If they need to propagate in the soil, like in an aggregate, they're there. You don't need to have them in a product. Um,
Yeah,
I,
that's how I've felt about it. Yeah, yeah.
I,
The fact that there's a handful in there, it's like, okay, well, they're part of the community.
yeah,
And yeah, if there's a need, because they're the garbage men, they're the cleanup, and they're an essential part of that ecosystem. So we respect that. But yeah, it was kind of, yeah, we expect them to be
yeah,
there,
yeah,
and they will be there if there's food for
and typically, like in a starting a new client on heavily disturbed soil or compacted soil, I like to use the facultatives. And I know you mentioned that you have facultatives in your product as well. The ones I really like to see are rotifers and stalk ciliates. Now they're big, so they don't really unless you can get them into a cyst form, they don't do well in application. Is my experience. But typically, as
food.
long as you get the environment to a point where, like with the stalk ciliates, if you get the oxygen up to a point where you see them cyst open, you're really
Hmm.
close. Like I don't know if you've ever observed that under a microscope, but I think it's
No,
between 7 and 8 parts per million. They'll cyst, and then I'll apply them, and I'll come back a couple weeks later and do a whole bunch of direct microscopy, and I can find them, and they were not present prior. So I know I can seed them or inoculate the soil with them. But I've had great results with that as the first application in spring when everything's wet, because they'll really do well. And then as the summer comes in, I'll just use just the food, and in the fall I'll do a full aerobic, and I can convert a field in 1 year by doing it that way, because now I've gone through like the Winogradsky column, showing the different levels of dissolved oxygen by mimicking nature and following nature's rhythms or patterns. So you mentioned that you have some facultatives. Are they single cell? Are they bacteria or fungi or both?
both.
Gotcha.
Yep. Yeah, and if you look at the source materials that we use, so we've collected biological samples from like 17 or maybe more, kind of virgin habitats, biogeoclimatic zones around the world, from Arctic Circle to tropical forest and alpine meadows to mud pots and mud flats and everything in between. And so we collect all this biology, but we build these mother cultures. And so if you think about where the biology comes from, and all the different habitats that are in the soil, you have, even in a good healthy aerobic soil, you have anaerobic
Hell yeah.
micro habitats. And so that's one of the reasons why we have such a good facultative population, is because we may raise them very aerobically and they'll just have that metabolism, but they have the ability to switch back and forth. And we want that, because there are some important things that the anaerobes can do in terms of redox, nutrient cycling, and some things like that that are important. So
Yeah,
like to have those guys. So
that was another thing that. Oh, are you still there? Okay, good.
yeah, yeah, I'm there.
That was
Yeah.
another ass whooping I took from Elaine. One day she was, really yelling at. She had a group of interns that she brought with her for the summer, and they were there to study under her, and so she was talking about anaerobes and how she was really upset with some of the students because their compost they were supposed to be building was just purely anaerobic. It wasn't even close to being decent compost. And so I went and pulled her aside. I said, Elaine, why are you so anti, anaerobes? Like they're part of nature. Like they're part of the whole system. Like how can you just say, no, they're bad, they're bad, they're bad? And she hard right in front of all of them. So I was like, okay, I'm gonna go off and do a little experiment. I went out and I found I call them indicator plants. Most people call them weeds. And I ripped up the plant with the whole, what I want to call rhizo sheath. So all the soil intact. And I cut it, horizontally. And then I took soil samples from, all these different areas of that plant and microscoped it. And I found a number of anaerobic pockets that were just almost purely ciliate. And I went back to her and I said, look what I found. And I don't understand why you got so angry at me when, all I was doing was asking a simple question as to why you're so against this. I go, we digest anaerobically, like what we eat. When it comes out the other end, it's not pretty smelling, right? So we know that's an anaerobic digestion. So here's a plant doing the same thing. Don't you think that they should not be demonized as bad organisms? And then she told me a story about how she almost got her name destroyed and her reputation ruined, and lost her funding as a result of a PhD student that was studying under her. I don't know if she shared that story with you or not, but this student took everything that she said and did the exact opposite. She took fresh horse manure or fresh cow manure, slop, added a ton of molasses to it, and poured it on a plant, killed the plant, and then said compost teas don't work. Well, she disappeared, later showed up, some other state, extremely well off. And, that's not cool, right? So, again, the industry's been trying to snuff her for years. And she's had friends that got snuffed as a result of, their work and trying to get the information out to the masses. So, that's why she said, I have to be so careful because, people will interpret what I said or only remember partially of what I said. And then, this will come back like a boomerang and hit me in the back of the head. And I'm like, oh, okay. I appreciate that. I can respect that. But it made me lean back toward understanding that relationship of the soil aggregates and how critical that was. And that launched me down, well, shortly thereafter, launched me down what I call soil engineering 101. Understanding what a clay platelet does, understanding how a silt reacts, understanding sand and what it's made of, as well as organic matter. I mean, those are the 4 pillars of soil. That's what all soil is, and my beefs with the soil science world calling silt as a mineral. Well, no, it's an organic form of mineral. It's not a crystal form, and there's a big difference. They have radically different properties. Specific gravity. Like if you stick your foot in sand, wet sand, and pull it out, it don't stink. You stick your foot into a silt bed and you pull it out, it smells like hell. So it's organic matter. But anyway, I'm kind of going off topic here. My point is that understanding how important the whole system is the key to turning dirt back into soil as quick as possible. And so kudos to you for understanding all of these pieces and aspects, and actually, getting into 40 states. I mean, what is your production capacity like these days?
Well, the peak season, we're typically shipping out at least 4 or 5, either tanker loads or truckloads a week.
Are you liquid and powder or?
All of our microbes are all, well, with the exception of one product, are all liquids, and all of our microbe foods are wettable powders.
Gotcha. So the microbe foods, this might be a fun topic. What are they derived from? Are they like plant-based or animal-based or?
Well, yeah, there are some animal-based components to it. Really just, we try to think of it as a complete food ration. It's like, okay, what all, does it take to grow more microbes? And of course, we've got our own formulations that we grow all of our cultures. So our microbe food products look very much like the rations that we feed the microbes to grow the products in the first place. And so when we look at it, we're looking at different sources of amino acids. So we want actually a complementary set of different types of amino acids, because they do have some different functions, and different microbes use some and not others. And so again, we're trying to establish maximum biological diversity. So we want to have a really diverse food source. So a spectrum of different amino acids from different sources, Same thing with carbohydrates. We have very little simple sugars, but there's a little bit of that. And then minerals. So all of the building blocks from carbon, of course, our most fundamental one. And then all the rest of the nutrients in the right ratios. And so that's what a food product looks like. And of course, we're very careful about low salt index and very clean in terms of the non-nutrient metals concentrations, typically very fine particle sizes because we want it to go in solution and stay in suspension very effectively, and be very bioavailable because the smaller the particle size, the larger the amount of surface area and the more microbes can chew on it at once. And for us, the food component is really, really important because remember, we put all of the microbes in stasis. And the microbes will stay in stasis until they have suitable habitat and food. So when we mix our food with the microbes as we're doing the application, putting it in the field, the microbes immediately wake up because microbes are opportunists. They're not going to sleep through a meal. So they wake up really quick and they attach themselves to the food, literally. And they'll take a ride through the irrigation system or the sprayer. When they land, they have UV protection because some of the components we put in there are carbon-based that give us UV protection, and food and habitat. And so they wake up and they colonize efficiently and they immediately begin consuming that food and propagating. So we figure we at least double the population of what was applied just from the food that we put with it. And it also sustains the metabolism. So we want to have that prolonged, presence and activity of that population. Because we didn't really talk about it, we almost kind of bounced off of it, but really the restoration process. So, here we've talked about all these production soils that are pretty impaired biologically. And yet you can't repopulate everything all at once because there's certain microbes that are really good early colonizers, like some of our bacillus are really good early colonizers and they kind of pave the way. And some of our fungi are not really successful in colonizing until there's a fairly full complement to the rest of the set of biology. So by having this complete food, one, you give the later colonizers a better chance of colonizing. Two, we come with this huge consortium of microbes that was grown together. So they're kind of this self-supporting community. So again, we get much higher colonization rates. And then the other component of it is time. Give the time for the microbes to colonize and do their job, and then successive colonization. So there are some species that are not going to be successful in colonizing until the second, third, or fourth kind of application. So when people sometimes say, it's like, well, how many times am I going to have to do this? It's like, well, it depends on how many things that we're continue to do that are adverse to the biology. So we may be taking 2 steps forward, but every time you're putting on that systemic pesticide, you're taking 1 step back. So, we try to figure that into our thought processes in terms of how we successfully colonize and then sustain and maintain and build that soil biology and restore the soil.
Dude, that brings
and food's a big part.
Yeah, that brings up, well, a couple of questions. Let's start with food first. Is this at part A, part B when it gets to application, or have you figured out, oh, okay, there you go. All right, that answers that, because I'm like, how can you put enough food in there to do that without creating this, plume while you don't want it? So that's cool.
We do have one. Yeah. So in general, that is how we do it. We keep part A, part B. Don't combine it until you're going to put it on, because as soon as you expose them to food, they're off to the races. We do have a product that we work with. We have several distributors, and they have developed their own set of products which integrate our biology and also microbe food sources. And so we have come up with a couple different strategies to stabilize that. So, for grower production logistics and just simplicity, it's kind of an all-in-one. So it's got the food, it's got the microbes, it's just been stabilized so that they behave themselves until you put them in the soil and let them dilute down a little bit, and then they're off to the races.
Yeah, I think you missed another piece of that, because you are providing UV, food, water, and cover. So they got everything they need to do their job. All right. So then this leads to the next question: is like, if in a perfect world, your farmer says, "Okay, I'm going 100% synthetic free. I want to go completely regenerative." And what are you going to tell me? How many applications do I have to do? Is there a testing protocol after every season that we go to? Are we doing chemistry or just biology? What is the protocol for that?
Sure. Yeah, we have growers that are kind of across the entire spectrum of, they're going to maintain their synthetic, conventional programs, and we just kind of dovetailing in and complementing that. And other ones who say, no, we're going to make the whole transition here. And for those guys, well, actually, for all of them, we do a fairly similar set of tests and protocols. So we might start out with a soil test where we do a total nutrient digestion as well as a saturated paste. So total nutrient digestion, we're looking at inherently what is in that soil, what is the full nutrient potential of that soil. The saturated paste is telling you what's available now. The difference between those two is biology. So oftentimes we have growers, this is going to go slightly off track here, but what you asked me earlier is like, what gets growers to decide they want to do this? Well, one of the things that gets growers on board with this is they'll look at the total nutrient digestion and they'll say, God, I've got like 30 years of phosphorus locked up in my soil.
I know, right?
and every year my plants are phosphorus deficient. And every year my PCA tells me the fix is to put on more phosphorus. It's like, well, let me off this crazy ride. This is stupid. And so we help them understand is like the difference between the soil nutrient potential and plant nutrient status is biology. So we would look at the T&D as well as saturated paste. So that tells us what nutrients we're working with. Microbes are very good at delivering nutrients to the plant, but they can't deliver stuff that doesn't exist in the soil.
Yep.
So that's part of what we might address in the program is like, hey, you just don't have any of this. So part of what we're going to do is we're going to look at, cation-based saturation. So it's like you've got this overwhelming propensity for this one nutrient to crowd out other ones. So we'll integrate that kind of into our thought process in terms of how we address the nutrients. Then we can sometimes we'll do a metagenomics on the soil, so we'll see what the inherent current set of biology is. Oftentimes, well, we're looking for functional weaknesses that help us choose which one of our products we want to do. And also a little bit about how aggressive we want to be, as well as looking at their pathogen complex, because sometimes that can lead us to do a different set of products for an intervention. So say if there's a very high complement of, say, fungal pathogen pressure of a particular species, we would choose a different set of products to address that. So then from those three sets of data, we would come up with our nutrient plan for the program. So we can oftentimes I try to start the crop with the decomposition of the preceding crop. So soil biology is a lot about momentum. And so if we can start working that ground, a good 6 months before we're actually going to be planting into it, that gives us a huge advantage. Then we can talk about seed treatments or transplant water drenches where we've inoculated both of those, first irrigation at planting. So we've got all these sorts, and then foliars, and then subsequent irrigation applications. We got all these application opportunities. So we really dovetail that into the farmers' practices. And because we're pretty versatile in terms of our ability to tank mix, we don't really usually end up asking the grower to put on any additional passes of material than what they're already doing. Then a key component of that transition, away from a purely synthetic program is to do sap analysis. So we'll do sap analysis of the plant tissues. So for anybody who's not familiar with sap, what we're looking at is the liquid part of what's flowing around in the veins of the plant. So we'll take a set of plant tissues, leaf samples from old growth leaves, as well as new leaves. So we send that off to the lab. We get pretty rapid results. 24 or 36 hours later, we'll have SAP analysis. So that tells us pretty near real time what the nutrient status of the plant is. And so that allows us the opportunity to course correct. So if we've seen what the nutrient potential of the soil is, what the nutrient availability of the soil is, delivered the nutrients in the ratios that we need for each crop growth stage, because that's our strategy when we're doing these integrated programs, then we monitor and making sure that we're on track for hitting those peak nutrient demands that occur at different growth stages. That allows us to intervene. So if we start to fall short, the biology is not able to deliver the complete complement of what we anticipate the plant is going to need. It allows us to do a foliar application and kind of catch up. So it's remedial nutrition, but it's before we actually have the shortage and the yield impact from the shortage. So it works really well. I tell growers, is like, you wouldn't want to fly without a net. So we want to have the data that tells us that we're on track and we're doing the right thing. And it's been very, very successful. I mean, fairly regularly we'll cut growers back 50% on their nitrogen, 35% on their phosphorus, and we'll end up having actually a higher nitrogen status in the plant even after we cut the nitrogen back by half. And what's cool is the SAP analysis will tell you the form, not only the quantity of nitrogen in the plant, but the form of nitrogen. So it'll tell you if it's total nitrogen, which was really measuring amino acid form of nitrogen, which is kind of the ultimate part of the process for synthesizing the nitrogen in the plant. It'll also tell you the nitrate and the ammonium concentrations. And so the microbes, when they're delivering nitrogen to the plant, are delivering it in amino acid form. So, and that's exactly what the plant is going to do with all this nitrogen we feed it. Doesn't matter what form you feed the nitrogen, whether it's in nitrate or urea or ammonium or whatever. Ultimately, that plant is going to convert that into amino acid. So a nitrate takes 6 molecules of water and some other minerals like magnesium and sulfur or other nutrients, depending on the type of amino acid, in order to translate that nitrogen into an amino acid. So that's water and energy and time that the plant has to invest in creating amino acid. Well, the microbes are already delivering it to the plant in amino acid form. So it gets to skip all that process, which when we talk about over-fertilization, oftentimes we're talking about over-nitrification. And when you have way too high nitrogen or nitrate concentration or ammonium concentration, you have all sorts of production problems that occur from that. So, I oftentimes will say that half of the production problems that we have, and that's probably being pretty generous, are self-inflicted. Things that we do that actually actively contribute to causing the problem in the first place. And over-nitrification is definitely one of those. So by taking this approach where we're allowing the plant to dictate to the microbes what nutrients it needs in what quantities and what ratios and what timing, basically it's elegant because all you're doing is you're just trying to make sure that you're giving the microbes the opportunity and the building blocks to support that in the plant. And the plant kind of lives optimally at that point. We start to see performance out of these plants and levels of health that you just don't see in any production practice, let alone even the best conventional. And we'll do it better and cheaper.
You become a plant steward, not a director, not telling you what to do.
Yes. Yep.
Now, as far as
it puts you in it's a service role, really, at that point. We're not dictating to the plant. It's like we're in a service role to the plant.
Yeah. And you're in service.
What can I do for you today? Yeah.
So in metagenomics, are you using biomakers or someone else?
I have about 4 different metagenomics companies that we use.
Okay.
Matter of fact, I just got results from one for the first time today.
So I started working with this company called Biomakers a couple years back now, and I really like them. They're very inexpensive. Their turnaround time is very reasonable, and they identify a lot of what you're talking about. It's saying that, well, based on these communities of bacteria or fungi, we can see that they are producing a fungicide or they're producing an insecticide. So there's obviously some pressure that is perhaps not even shown up yet that you need to look ahead at. You need to correct it. And I found that tool with the chemistry saturated paste. I usually do a water quality test, but it gives you that package that you really can kind of see or predict the future that you're going to have to deal with. And that this is something that I'm sure you're well aware of, is that is if you can get the chemistry in balance first, that's really the only limitation of the biology. As long as everything, your traces are there, your molybdenum is there, your calcium, the magnesium to potassium ratio is right, it's so simple at that point. It's only when you have to go, oh shit, we don't have that, we're gonna have to foliar that in, this season, until we can course correct next season and apply the minerals, during the down season, that it becomes an issue. So I love the approach that you guys have put together as far as the operating procedures on how to transition. That's great. I mean, that's really very powerful tool you've built.
Yeah, I think we've been using biomakers for, I know, easily over a decade. Actually, at the beginning, they didn't even have a report. They just gave you the genus and species.
Right,
And
but
so
that
when we're
bee crop's the bomb. Their new product.
I'm going to take the opportunity to brag on my dad just a little bit here. He passed away a couple years ago, but when we were first digesting our first sets of metagenomics, it was the population, genus, and species. It's like, okay, I guess we got to figure out what these things do. And so we started characterizing each one of the microbes and what their function was. And then we started building the spreadsheets of, okay, what's my population of nitrogen fixers, and then nitrogen carbon cyclers, and ones that do all these different functions. So biomakers had just started. I think they were still in the incubator in San Francisco or the Bay Area. And
Central Valley, I think.
So we showed them the report that we were doing. So we said, look, we know growers, and there's no way the growers are going to be able to digest the form of what you just put out. It took us 10 days of dedicated research just to do this list. But here's how we want to look at it. We want to look at it in terms of these metrics. So if you really want to reach a broader audience, this is kind of how you need to format things. So that did become, I think, I don't know how far along they were internally on that thought process, but we actually gave them the first effective bee crop report, and that was my dad.
I love it. I love it. That's a great story. Kudos to your dad. I'm sorry that he passed. All right, so reeling it back in to the question at hand. In a typical farm application where he wants to go 100% regenerative, no-till, really wants to do it up, how many applications do you typically run into? I know there's going to be specifics, there's no one size fits all, but is there an average?
Yeah, well, I'll give you kind of the variables that are involved. So one fundamental is the economics of the crop. So if we're talking about corn, is like, whatever you're going to do, you better do it for less than $50 an acre, because you start going in a total cost above that, is like, that's not practical for them. So then you look at what are their, within that economic framework of what's kind of the sensitive threshold that they can tolerate. Now, for a strawberry grower, I might be at $1,500 an acre. But then you say, all right, now within his cultural process, is he irrigated or is he dry land farmed? So because that makes a big difference in terms of what our application opportunities are. And then within that context, we also say, what's the earliest we can get on? So if I had a dry land farmer, I would want to do a decomposition application in the fall. I would want to do a seed treatment if at all possible. And we have done a lot of seed treatments on things even that already like pre-fungicided, because it's hard to get naked seeds sometimes, and that still works. And then if they have any liquid on their planter, so either over the seed row or a 2x2 offset, a little less desirable. So that's the other application opportunity. So really, you have to dovetail into what the grower is capable of implementing. If it's just one thing, if it's just like, hey, the only opportunity we've got is seed treatment. It's like, okay, that's what we're going with. Well, it's a great bang for your buck because you don't use very much material and you do get a good response. So, I think that's not an easy way to answer your question, but in some cases with some corn growers in the Midwest, I think we might have four applications in a season, and with a total cost of maybe $70 an acre.
Okay, let me reframe it.
Yeah.
How many applications under the circumstances that you just explained until you achieve what we consider soil tilth, where you can just stick your hand down into the soil?
Mm-hmm.
That's my measurement of soil health.
Sure. A lot of variables there. Well, soil aggregation, which is really what we're talking about there. And of course, you can have all sorts of like a base saturation issue, or which would be in this case salts, which will disaggregate soil and then cause flocculation. So it really depends on what the limiting factor is of the soil in terms of soil aggregation. One thing I do see a lot with my Midwest guys, so some of these guys have been, quote, regenerative for 20 years, meaning that, they've had no-till and cover crops for 20 years. And yet soil still pretty tough. You look at the soil micro population, good bacterial representation, still no fungal. And that's because in a lot of the cases in their cropping system, they kind of double down on the glyphosate because they're no-till and they've got cover crops. And of course, that's really, really hard on the soil fungal population. So in the case where I've got a good bacterial population, but no fungal population, for my regenerative guys, I'll get in there. We have a product called Metagrow F, which is our fungal dominant one. And it really builds soil tilth quickly. So, I mean, you would definitely be able to see a reduction in the pounds per square inch, on a penetrometer in one season. But again, there's just a lot of variables in terms of, again, base saturation of things like in salts, physical soil chemistry, soil structure, water quality. I mean, so all of those would go into that. So sorry for not giving a more definitive answer, but those are the variables.
And it's fine. My question was more focused on someone that would never use glyphosate. Right. I understand there are regenerative farmers that say they're regenerative, but use, these pesticides or herbicides. But in my mind, that's never working with nature. You're never going to make soil regenerated. You're only organic at best. You've got to be working with nature. You've got to have earthworms. I mean, that was one of the things that Kyle achieved in year 2 was he called me panicked. He's like, oh my God, I used winter rye. I should have used clover like you told me, but the clover seeds were too expensive and the rye was cheap. He goes, I've got to get planting. I've tried crimping the winter rye, but it just stands back up and it's going to outcompete when I can't crimp after I plant. I'm freaking out. And I said, don't worry, just till. I said, all you got to do is take your discs and set them so that they're only about an inch into the soil, and you'll still keep the other 4 to 5, 6 inches of fungal related organisms intact. And he goes, but that's never going to work because I got, rolls and dips and tire tracks. And I go, look, nothing's perfect in nature, right? It's not supposed to be perfect. So look, if you get to a spot, like even if the discs just touch the top of the surface, they're going to kill the plant. They're going to slice it and dice it and thrash it. If there's an area you got to go back and hit it again and drop the plow a little bit more, do it. But the goal is not to go down 8 inches or 6 inches, typically like you do in the past. And he's like, oh, okay, all right, I'll do it. So he did it. Calls me back a couple days later. He goes, all right, everything's done, but I'm having this problem. I go, well, what's the problem? He goes, the soil's sticking together. It's in clods. I'm like, that's good. That's aggregation. That's what you want, my friend. That's a great step forward. Before your soil was so dense you couldn't even get your finger to penetrate in it. And now you're getting these clumps, so you know that you're starting the aggregation process. He goes, I got another problem. I go, what's that? He goes, I got earthworms everywhere, all different sizes. Well, that's not a problem, buddy. That's what's supposed to be. And he's like, but my neighbor, he's 85 years old. He came out and he was like, I've never seen a worm in this field ever in my whole entire life. And I'm like, yeah, that's the whole point, is that the synthetics nuke those. Those guys are opening up channels for the rain to get down and storing the aggregates. So when you go through the drought, you're going to be okay. Or if you get a large gap with no rain, you're going to be fine, and your neighbors are not. And sure as shit, that year they had a drought, and his plants did fine, and a lot of his neighbors, they collapsed. They just called in the crop insurance because there was just no way that they were going to get enough to harvest out of them. So that was where I was framing that question from, was like, in a perfect world with no synthetic applications, do you think that you could hit aggregation in a year or two from starting and to a point where the farmer no longer has to use anything because you've colonized? Other than maybe
well, that's bringing up the macrophytes, and thankfully I joyfully get those calls a couple times a year where people are like,
isn't it awesome?
I have never seen earthworms in my field before. My dad has never seen earthworms in that field before, and this is like some tough Texas ground too. So, they're just, couldn't believe it. So, things are starting to work right when you start getting those trophic levels of life successfully being represented, because they do such important functions. They're the pioneers in tunneling and creating, water pathways, air pathways, root pathways. And that also means that, you've built the rest of the soil biology. So by the time you get to that point, that you have to have established a soil fungal population.
Mm-hmm.
And then that's when you're going to get the tremendous stress resilience out of those plants from things like drought, is once you get that endophytic fungi colonization, you get a great deal of stress tolerance. Oh, I was going to tell you one other metric that I think might make you very happy. And we see it much more often than I ever would have thought possible. So I talked about how the microbes are feeding the plant, and because the plant has higher nutrient status, it has higher photosynthetic efficiency. Therefore, it's got more photosynthetes to share with the microbes as exudates through the roots. And those exudates, of course, in the form of sugars, which are mostly carbon, just a carbon backbone. So we can see right there in the rhizosphere, you can see the zone that they're creating of all this high carbon environment, because it's black. And one thing, a metric that we see much more often than I would have ever dreamed was possible, let alone kind of something that we see frequently, is integrating these programs. We see soil organic matter climb as much as 1% in a year. Mm-hmm. And I wouldn't have thought that was a reasonable target at any given point, but we keep seeing it over and over again. And yes, we're creating more biomass, and the biomass that we're creating, we're capturing in the soil better, so there's better carbon capture. But by far, the mechanism that I think is responsible for this is that photosynthetic exudate through the roots. That's where it's happening. It's the carbon pump. Mm-hmm. And so the microbes, of course, capturing that, turning it into their physical bodies, they die, that turns into soil humus, turns into soil organic matter. So that does so much. You bump the soil organic matter by 1%, you've increased your soil water holding capacity by, I think, a couple 100,000 gallons per acre.
It's
I mean,
ridiculous.
that's big.
Yeah, it's ridiculous. A couple years back, I
Incredible.
stumbled. Well, actually, it's probably more like 3 years back. Or a friend of mine stumbled into Leighton Cartufa out of Colorado State. First time anyone's ever really documented through a peer-reviewed white paper on soil organic matter formation. And the highlights of the paper was that dissolved organic matter or dissolved organic carbon is typically 1 to 2% of the overall soil organic matter pool. And it's responsible for a lot of the most powerful tools for the plant. And it comes typically from exudates and or from rain that has washed through leaf litter that's releasing humic acid down into the soil. And so that was like one of my aha moments is like, for years, this is my process. You'll get a kick out of this. So I take my fish mulm, is liquid. I take worm castings, which is solid. I make my own biointensive compost, and I mix a ratio of compost to worm castings, and I throw it in a washing machine that I converted. And then I put in 5 gallons of mish mulm, which is usually diluted because the stuff I get is so strong. And then I wash it, and I make this humic acid, which is like completely biological bomb. And I apply it. I started off in engineered soils out on the East Coast doing massive public spaces, parks, places that had a lot of pressure, like tournament fields, where the soil was engineered. So it's 99% sand, 1% organic matter. And the gentleman that I was working for could not get fungal establishment, could not get protozoa to take hold, couldn't get it inoculated. And he was using a compost tea, not a compost extract, where I was an extract. So he started applying my product on his fields, and he would get 6 to 8 inches of chocolate looking soil. And it still contained, the engineering was perfect. The golf ball rolled over, the cleats didn't sink in. The field was populated for a concert and came right back the next day. So they were blown away, and we had, incredible fungal, 1-to-1 fungal to bacteria, protozoa everywhere. And this was the first time that I understood why that this worked so well. This humic acid, biological humic acid, was that it bonded all those sand particles together in a way that it would hold moisture and hold enough humic acid for these other things to colonize. And so I would highly recommend you look into her work. I mean, it's something that makes it a lot easier for you to explain to your farmers why this stuff works, is because you are creating that response mechanism that creates the soil organic pool. It builds it. And a lot of it is due to like the exudates coagulating around soil particles. It has to do with excess roots that don't necessarily slough in the summer, so that they're stronger, they're thicker. The plant doesn't have to work as hard to burn its ADP on converting sunlight into exudates, because you're kind of creating the excess exudates that would normally fuel the biologicals, by the biologicals fueling the creation of the foods and folding the enzymes and creating peptides, etc. So she really was the first person I've ever had explain to me that critical piece of the puzzle that's missing. Now, typically we would have bounced to questions 9 minutes ago, almost 10, and you've got a decent amount, so I don't want to let the audience down. So Ken, why don't we bounce into questions? And we're definitely going to have him come back, because we only scratched the surface on this conversation. So
we got lots more to talk about. Yeah.
Yeah. Big time.
Yeah. So let's start with Jeff here. I hope there isn't anything bad in the worm juice. Testing is very expensive down here.
All right, he's down in Australia. Are you international, my friend? Can you ship internationally? No. All right. So, Jeff, unfortunately, you're not going to have the opportunity to play with his product until, if ever, he gets to that level. But typically, as long as you're aerating your worm juice and you're not applying it to highly aerobic soils, you can't go wrong. If you take nasty smelling anaerobic, what we call leachate from the bottom of your worm bin, you're going to take things backwards, my friend. So definitely don't do that. You might want to add to that, David.
Well, I think you nailed it. As long as you start out with source materials that are safe materials. So I don't ever use, like animal meats. So I'll use some fish hydrolysate, but no fish or no meat scraps or things like that, and no raw manures. So you kind of stay away from a couple of those things. If you manage your gas exchange, so keep a very aerobic culture, and don't allow a lot of anaerobic metabolites to form in your tea, then you should have a safe product. Just don't drink it all at once.
Yep. Okay, next question from William. Do you ever work with crop insurance to get these methods verified with them as satisfactory methodology, or at least to save them money?
I haven't worked with the crop insurance folks, but I have had some of the budgets called in from the bank. So a conversation with the bank, and it's like, okay, we're approving every line item in the budget. So I don't usually get pulled into those conversations, but we, honestly, we should. So I would expect that more in the future.
It's interesting is I'm amazed you haven't run into that gauntlet. That was Kyle's greatest fear, was that if he doesn't use synthetics, the bank is notified, and then he doesn't get his loan for the season for his diesel, his seed, and all of that. So he's automatically out of business. And so what I told him, I was like, well, look, Kyle, there's a couple ways to get through this, right? First of all, tell him you're doing experiments, or you're doing an experimental organic soil amendment. So, and then if you're probably going to use synthetics the first year, but not the second year. So he did, and he was all right. And then he was panicking, and I'm like, look, Kyle, just buy the fucking fertilizer and sell it to your neighbor. Now you're on record for purchasing it, so the crop insurance can't deny you, but they didn't know whether you applied or not. Who cares, right? So this is a big issue that we have to deal with. And I'm amazed that you haven't run into that. Now, maybe the bankers you're working with are more sophisticated than the smaller, like, less than 1,000-acre farms. But typically the crop insurance is the biggest deterrent in moving into these regenerative organic practices, because you can't get insurance if you don't buy the fertilizer that they require that you buy to grow your plant, or for them to insure your plant. So it's a conundrum.
Yeah. Okay, for our next question, chelated minerals, is that what you're using for your feedstock?
Yes, some of the minerals that are in the microbe foods, both for growing the population as well as the microbe foods that we sell, fertilizers, are chelated minerals. Usually they are amino acid chelated. I do not use anything like EDTA or any of those other chelating compounds. It's important for availability, and actually that's one function that we didn't talk about the microbes doing. So we mentioned that microbes deliver a lot of nutrition to the plant. Microbes actually have, or some of them have, what's called a cytophore function. And cytophore is just a chelation structure that some of the microbes have. So chelation, of course, is like a chemical claw. So if you are chelating a cation, you have a chemical claw with very strong negative charges on the tips of the claw. and it literally can pull the cation out of other mineral combinations. And the microbes will do this actively. This is part of their conversion of soil nutrient potential into actual plant nutrient status. Is they're pulling those unavailable things for their own uses, actually also as a biocontrol weapon, and also specifically to feed the plant. So yeah, chelation's happening at actually all sorts of levels in this.
Mm-hmm.
And so you don't use any like rock powders or flours, using more of a
Oh, sure. Yeah, we
Oh, you do? Okay.
use, yeah, because that's part of what the function that we need to build the biology to do. So when they land, they have to be ready to work for a living. So, somebody puts soft rock phosphate on. It's like, well, without biology, just sits there. Could be there for hundreds of years. When we talk about weathering stuff, it's biological. It's not weather, unless you have an acid rain or something like that. So the microbes have to be prepared to have metabolism to produce the enzymes to break these things down. So, yep, we make them work hard, and yep, sometimes a ground mineral is what they get for dinner, or it's part of what's on the menu.
Is that in the culture that you're using that, or is that in the food part B that you add at application? Both. Okay, cool.
Yep. Yeah, we also will combine our biology actually with some bulk mineral applications in the soil. So say somebody's putting out, soft rock phosphate in the field. It's like, well, let's put some of our phosphate solubilizers in with that, because they're going to be there to start translating that nutrient potential into nutrient status.
Mm-hmm.
We also do that with things like calcium silicate.
Cool. So our next one, bricks analysis, like you were talking about, using the saturated paste test. For most home growers, like a gardener like me, would a bricks analysis even come close to giving you an idea?
Yeah, actually, well, there's kind of two different forms of bricks analysis that they're very similar, but they're not calibrated the same way. So if you're at home, you can literally use a press on your leaves and squeeze enough juice that you can literally see in a refractometer what the bricks or the soluble solids are. And so that gives you kind of a gross metric on photosynthetic performance and mineral content. So it's a useful tool, and of course, it's something you can do for yourself, quickly and cheaply. Once you got a refract and a press, you're good to go. That will give you different numbers than you get from, say, the bricks from a SAP analysis. So they're measuring the same thing, but they're not kind of calibrated the same way. But I find that the bricks that I get out of a SAP analysis is highly useful, because it really is telling, well, that and the sugars. So the bricks is everything that's soluble solids, which is mostly sugars, but it's also dissolved minerals. The sugars tell me it's an exact measurement of what's going on with photosynthesis. So, and to me, if you can get the photosynthesis for a plant working right, very high functioning, everything starts to go right. I mean, it just is a cascade of success. So I think it's a tremendously useful tool.
Yeah, and I agree 100%. Typically, most homeowners aren't going to do a SAP analysis, but they can do a bricks test. And it gives you a similar, like you said, a less complicated matrix that gives you a general idea. And if you can get your bricks level up to 20, you're almost bulletproof, at least in my mind, as far as pest infestation. So that's the target. Typically, you'll see 8 to 10 on plants. But if you can get the biology in play, you'll get the bricks up, and then you're, like you said, now you're hitting on all 12 cylinders.
And guys, if you're looking for, a press and a bricks meter, Blue Sky Biochar has an excellent package. It comes with scissors, actually a 5-blade scissors, a press, charts, the whole 9 yards. So That's Blue Sky Biochar. No, our channel doesn't get a kickback from them, but we recommend their product because they have an excellent product.
Yeah, and it's only $139 plus shipping and handling. It's very reasonable.
Cool.
So our next question, I fed wild rabbits willow branches. They stripped the bark in my rabbit crap trap. I collected the crap. What was I thinking? And will it work? I know it smells like a hospital.
So that's I would say low and slow, my friend. There are all kinds of properties in different plants that are doing different things, like fighting off other plant competition. There's a number of plants that have those defenses. So if it smells funny or unusual, do small practical applications and observe. Don't go ballistic, because you may cause a situation where you're killing the plant that you're trying to grow.
Good advice. Yeah, that's universal. One thing I would say about the willows is they have a very interesting characteristic where they are a high source of salicylic acid.
Mm-hmm.
And so salicylic acid, of course, we know as aspirin. It's a fantastic antioxidant, very, very strong antioxidant. So those would be the pluses, but also the cautionary words of Leighton is like, tread carefully. But it actually could have some neat characteristics.
Yeah, don't be a moron. It's all about balance. So our next one, want to know about my deer poop.
Oh, I love deer poop. It's a cold poop. You don't have to worry about it being highly anaerobic. It's a slow release manure. I mean, look, why do you think the forests are so abundant? Now, again, if you get an imbalance where you have a herd of deers with no predators, they're going to chew everything down and cause problems. But generally speaking, if the forest is balanced, you have a wonderful understory growth that support the animals, the deer specifically. They leave the manure that feeds the more mature trees to keep the canopy thick. It's part of the balance. Any cold manure, llama, rabbit, deer, are wonderful additions for either your compost pile or for fertility in your plants and your gardens. I mean, think what they eat, guys. They're eating really good stuff. They're eating well. So good in, good out.
And allow the biology, I think it's best if you compost it first instead of just trying to throw it on directly, because then you can really get out of balance again. You can become a moron again. And so if you're running it through your compost, you're allowing the biology to break it apart, then you're going to get a much greater benefit, because, it's like us eating fermented foods. It's better for our biology in our stomachs because it's partially broken down already.
Ken, what do you think Cheeto's trying to tell me here?
He wants to go for a walk, Dad. Come on, Dad.
We have a routine every day at like 3:45 or 4 o'clock. We go for a walk. They get to sniff and pee, and we come back and have dinner. So he's notoriously for doing this, right at this point in the time. But anyway.
Well, so that's a lot more about deer poop than I ever thought I would learn. But I appreciate that. That was, I didn't know. Actually, related to that, I mentioned earlier that we do seed treatments. And so one of the companies that we work with is Green Cover Seeds. So they do sell cover crops or their seeds for food plots for deer and other game animals. And tangential to that, we've actually been using our Metagrow F product, our fungal dominant one, as a feed supplement for both grazing and feed cattle. And we've been seeing a tremendous response from them. And what we're seeing is, one, we can regenerate the pasture, the rangeland faster because we've inoculated it and we're helping it grow more vigorously, but they're also colonizing their rumen from all the biology that they're consuming as they're eating their forage. And we've seen the feed efficiency and the weight gain of the animals go up with that inoculation. And it's actually even changed the form of the fatty acids in the meat. So we're getting a higher meat grade because we've raised the fat content of it. But we've translated the omega-6 inflammatory fatty acids into omega-3s. So it's the healthy, non-inflammatory fatty acids. So much so that they're grading out. The omega-3 concentration has been as high as salmon. So I've been trying to get them to do a campaign to say beef more heart healthy than salmon.
That's fantastic. Now, did you feed the pure biologic to the cow directly, or was it just through consuming the grasses?
Both. Yeah, both in the we'll spray it on the pasture and they'll get it that way. It can be actually in the water in the pasture, and it also gets in the feed mix kind of through dosatron in the feedlots. Nice. So we're still at the experimental stage, but all the data is coming back, just amazing. And again, it's the same thing that we talk about with human health. It's like we need all this biology to help us process all this stuff. And if the fungal component is missing in the rumen of all the cattle, we can make the animal much healthier and much more efficient and much more nutrient dense.
Well, definitely keep us posted on that. I know, Kyle and a lot of these smaller farmers are actually leaning toward animal husbandry because out of desperation. They're getting squeezed so hard on the crops, like you said, the commodities market and all this other nonsense, that they've got to diversify. And I know Kyle had, I think, 10 head that he was going to bring to slaughter this spring, but he's looking to increase that next year. And so that's the key, is that if you have those omegas in your meat, that your meat is worth way more than the feedlots, the crap that we get in general public. So definitely keep us posted.
And one other benefit that's I just think is so elegant, and it's just how nature works, that I love. So we're, in this case of the range cattle, we're just putting it in their water supply. Of course, as they're foraging and walking around and they're pooping all over the pasture, they're inoculating every place that they poop. So we're actually seeing the colonization happen that way. So instead of, having a boom sprayer and our ATV and foliar spraying all this grazing ground, the cattle are inoculating it for us.
They make the cattle do the work. I love it.
Yeah, that's how it used to be with all the herds, right? There was one thing I wanted to point out also is, the people that cycle through from the larger, your cattle, etc., and go right down, through the pigs and down to the chickens. All of that benefits step by step in regenerating your soil that much quicker. Look up Gabe Brown because that's how he's done his work on doing all the different types of livestock. Also, your larger livestock, especially if you have a compacted soil, their weight will crack that crust and you'll actually get puddles in those cracks. It'll help to regenerate your soil that much faster, breaking up that crust, especially in Texas and places like that.
I mean, can you imagine if they fed their cows or added to the water trough, the product that he's talking about, how much quicker that would occur? Because as they're dropping their droppings, they're inoculating those cracks. I mean, you're talking about, 10x quicker than, you could do it in any other manner mechanically.
Yeah. So,
well, they were talking about, we mentioned the macrophytes in the soil.
Yep.
Go ahead, Ken.
Go ahead, David.
So the macrophytes in the soil, I had reports of a big bloom of the dung beetles that was associated with our treatment, because I think that there's just, I guess, more fungal population for them to consume in their process. But here they are, they're rolling it up, they're tucking it in these little cracks. They're burying it in the soil. So, I mean, you couldn't ask for a better fungal colonization mechanism.
Yeah.
Agreed, 100%. I mean, and that's fungal food, right? It's organic matter. So that's just going to make the fungus go crazy.
Predator prey model. You got to have all the different layers through the
Isn't
soil.
Mother Nature just wonderful? Why the hell do we have to get in the way of her? Just be smart. Work with her. Don't fight her. Anyway.
I think we got in the way
time.
because people wanted to make money.
Yeah. Sad but true. Anyway, I think that was the last question, Ken.
Well, yeah, last question, but we did have Tom Fortune wanted to congratulate us on 175 episodes of the Soil Matters so far. So thanks, Tom, for reminding us that we've been here. You know, we're in our 4th season now.
Damn, I didn't realize that. Well, congratulations, Ken, and Lil for supporting you and all the hard work that you do behind the scenes to make this happen every week at this special time. And David, thank you so much for coming on and sharing your story and a deeper understanding of how you've moved and navigated through this very difficult pathway called business in the year 2025, or anywhere after 2020. It's been like a nightmare. So kudos to you. Keep up the great work. And yes, please come back on in, I don't know, 3 to 6 months, whenever you're comfortable. And let's continue the conversation, because as you well pointed out, we had really kind of just scratched the surface on where we can go with all of these things, like, horizontal gene transfer, biosymbiosis, remineralization, mega and fauna, and all of the potential things that can come as a result of it. So thank you.
Yeah. Well, thank you so much. Really, really enjoyed it very much. And, it's the growers who keep us going in the hard times.
There you go. And please feel free to let your friends and family and anybody else, your clients, know that you did this podcast, so that they can give,
we'll post it.
Good man.
Cool.
All right. Well, Ken, thank you again for hosting this. And as you can tell, I got a couple little doggies here anxious to get on their walk. So I'm going to say adieu, and we'll see you again next week, Ken.
You betcha. And Dave, thank you very much. And I'll reach out. We're actually booked for until August now, so maybe we'll try to get you back on in August or September.
Easy cheer.
Sounds great. Look forward to it. Thank you, guys.
Okay, guys, I'm going to end the stream. We will see you on Wednesday with me and Andy. So always keep checking back, guys. We'll see you soon.